Hey everybody, I'm Sal Frino. I'm a customer reliability engineer from Noble 9, and today I'm going to bring you from 0 to 100 on the SLO development lifecycle. So a little bit about me. I'm a customer reliability engineer at Noble 9, and I work with several of our customers to help them create and track, update, manage their service level objectives. In doing so, I try to help guide customers on their journey towards better reliability targets. And along that journey, we created something with several contributors that we're calling the service level objective development lifecycle. So that's generally what we're going to be talking about today. We're going to talk about, hey, what is this? How can it help you create additional SLOs? And then we're going to go through a couple different use cases here. One of which is fictional, but three others are experiences I've had working with customers we have to actually better track and manage their SLOs. So first off, is there even a general interest in creating SLOs at scale? And we did a little bit of a survey here, and you can see that there is a growing interest around people to create more SLOs. And when there's so much interest in a topic, it's important to create guardrails to help individuals and teams along the reliability journey. And we know sometimes people get too busy juggling operational duties to actually set it up or to do it themselves. So, with that in mind, we created the service level objective development lifecycle, which we're going to call SLOW DLC today. And you can see here that you'll find several stages of methodology that mimic the software development lifecycle, where you have several stages such as initiate, discover, design, implement, operate, and then a review step. And all these are meant to help guide the conversation and to guide the individual teams and the organization to understanding their systems and creating more reliable systems. Now, you're going to be like, whoa, slow down, Sal. This is too much. And you know what? That's all right. We made a handbook for you to look at. So if you want to get more detail or anything about that, go check out slowdlc.com and you can review the handbook or any additional steps there. But today we're just going to do a little bit of a brief overview. And with that, the first phase of slow DLC is the business case. And with this phase, as you can see with some of all the other phases here, we have accompanying worksheets to go along with it. But the main purpose of the initiate phase is to make a business case. Have a short document to say, hey, this is what we're going to do on our SLO journey. You really, during this, you want to identify your three primary stakeholders: the users, the business, the different technology teams. And you also want to identify what internal SLO teams will be in charge of the initiative. Will this be a team of SREs? Will this be maybe a group that's maybe based out of your observability teams? Maybe it's something that comes out of your PM side of the organization. Who knows? It could all be different, and I've all seen them have varying degrees of success. And something else you want to do in the business case is identify the why behind this journey and outline clear goals in which you want to achieve. And we're going to see this in some examples later. The next phase of slow DLC is the discovery phase. And here you want to figure out, what are users even doing? How do they expect your service to work? Are these expectations implicit, explicit? What are their end-to-end goals? And what dependencies exist for those goals? Do you want to understand how the service actually works, or just how various folks perceive they work? I know when you're going to see some examples here with microservice architectures that there's a lot of stuff going around. It's very busy, and it can sometimes be very hard to figure out what exactly are your bottlenecks or your dependencies. And that's why SLOs that focus on the user journeys are really helpful in figuring out, hey, what is actually contributing to that and maybe causing an outage that is partially why you're even going forward and trying to improve your reliability, because you've had either an outage or you want to be more competitive or you need to focus on your reliability as a whole. After the discovery phase, we have design. And in design, you need to actually say, all right, we've got a business case. We know what we're doing. We have an idea of what services we want to do some work on. Let's actually start digging in and figuring them out. Okay, great. What data sources are actually instrumented for these services? What indicators can we use to say, hey, are we having a good day or a bad day? What SLOs are possible today with our current systems, and maybe what might we want to design in the future to get us more to our aspirational targets? And then uh, you want to also figure out, once you have these targets and these metrics, what are some time windows or thresholds that make sense? That, hey, if certain events happen, these are the actions we want to take to actually defend the reliability of the service. And all this gets covered in the design phase there. Another tool to help out during the design phase is the Google Siri risk assessment worksheet. And this worksheet is not created by us, but it's a free public resource in which many folks have found very helpful in actually calculating the reliability target and what they can do to actually figure out if their reliability goals are actually reachable or not. So I would encourage folks to go and check that out. Next, we have the implementation phase. And here you're actually going to define what queries you need to write. How are you going to define your SLIs across multiple data sources? How are you going to share these definitions of these SLOs with various individuals and teams? Where are you going to host, charts and graphs? How are you going to calculate error budget and trigger various automation and alerts? Now, there is a suite of open source tools in which you can use to go forth and do this for you. I'm a little partial to Noble 9 because I would love to help you out in helping you implement your SLOs and on your reliability journey here. The next phase here is the operate phase. Now, I kind of alluded to this a little bit earlier, but if you're just keeping all your observability data and you're not really doing anything with it, you're just storing it for some reason. You're not actually, if you're not creating actions, you're not actually alerting on it. You don't have people that are making decisions based upon that data. You're just kind of storing it for sake. So during the operate phase, I generally like to coach folks to take action at risk SLOs. Maybe examine the data. Maybe it's a little bit misleading and you need to check up on it, or fine tune SLOs to, adjust thresholds, or maybe split one complicated SLO out into several smaller ones. And then also maybe you need to compare how the SLO degrades and figure out if there's other business impacts or other signals in which you need to incorporate to help you make better decisions later on. Now, with that, I gave a brief overview of the SLO DLC. And throughout the process, we have several contributors here from various organizations you could see here that helped us test and refine the SLO DLC. And yeah. And with that, we're just going to have one more look at the overview of the SLO development lifecycle, and you could clearly see how you have all the different steps laid out here in which can help you on your reliability journey. Now, next, we're going to actually start getting into some of our applied use cases. So first one we're going to have here is Wiener and there we're going to focus on the discover and design steps. Likewise, we're also going to focus on the discover design steps with Fortress Bank. And then after that, we're going to focus in Storm Cloud on the implementation steps, and then Streams are us for the operate step here. Now, note all these companies' names have been changed, with exception of Wiener just to protect different parties involved. So let's get into our first case study, Wiener A dog needs new clothes. So Wiener is a fictional e-commerce site from Alex Hidalgo's Implementing Service Level Objectives book. They sell pet clothing, and they recently had an outage that contributed to poor user experience. Let's dive in and discover how SLOs can help them become more reliable. The first step is the discovery phase, and we want to identify the user journey. As a user, I want to buy cute clothes for my pets. Sounds pretty reasonable. What expectations do we have around that user journey? It should work like a normal e-commerce website with quick and easy checkout. Also sounds pretty reasonable. What dependencies exist? We're dependent upon our hosting provider and our card processor. Okay, that sounds pretty standard. What have been some observed system behaviors? We had an abnormal site usage, which led to an outage in our catalog service on January 14th. Now this is starting to make some more sense. So One of the first things I like to do when designing SLOs is to get the lay of the land and see a service architecture diagram. We can see here they have a CDN, a load balancer, web app, several microservices, and reporting. Nothing too fancy. All right, let's try to relate this diagram back to what we learned during discovery. When doing so, it's evident that we need to look at the catalog service. Generally speaking, the first SLOs I recommend instrumenting are the availability of a service. If catalog isn't up, efforts to measure or do anything else with it are kind of futile. Here we can see that they've chosen to measure HTTP status codes at the load balancer. This is a good start. Let's continue to get closer to that issue that contributed to the outage. During the outage, we had increased time to write to our catalog DB. Great. We need to measure the end-to-end latency here. Let's map out the end-to-end flow for that path. So let's go back to the architecture diagram and looking at this, let's start designing the SLO for the first service that we can control, the web app. Let's start our stopwatch there and then following it across the catalog service before we finally get to the catalog DB. Cool, we have this mapped out. Let's start talking about various latency thresholds for the catalog service. Here we can codify what perfect and normal reliability targets look like for this service. This helps us establish a baseline for further conversations. Let's try to figure out what unhappy or sad levels would be for this service. To help us here, let's think about what actions we might want to take to remediate if the service degrades. Here, it looks like the team wants to send a message on Slack and autoscale if 95% of the writes to catalog DB exceeds 4,000 milliseconds. But then if the service degrades even further, such that 99% of the writes exceeds 45 milliseconds. Roll back, declare an incident, and investigate. These sound pretty well designed SLOs to me. Our second case study is Fortress Bank. Fortress Bank is in the financial services industry and is a card processor. They have strong contractual and regulatory incentives to ensure payments are made to individuals quickly. Just there, we could understand that they're in a certain industry, their motivations for needing SLOs and becoming more reliable, and their eventual goal in which they want to achieve. So, as we understand that, is able to slot in very easily into our discovery step here. Their user journey. As a user, I want to send money quickly to a third party. What expectations do they have? I should receive a notification that the payment is being processed. Okay. Dependencies. A third-party application gateway, clearinghouse, screening process. Okay, sounds reasonable for person-to-person payments. What are some observed system behaviors in which we can look at? What have we learned from existing performance data here? So when we first met with Fortress Bank, this was the initial service architecture, when you can clearly see it's composed of many services talking with each other. And after some discussion during discovery, it was identified that we need to bifurcate this into two distinct user journeys. In doing so, we ended up with two end-to-end SLOs that measured various latency targets. This, follows a similar process to what we did earlier with Wiener Schnitzel. We map out the flow and made it clear what services were in scope and which were out of scope. Due to contractual obligations, this first user journey had an SLA for 99.9% of the time. They had to send an acknowledgement of a payment that had been processed within 2,000 milliseconds. It's pretty fast. With that, we have our top end of the goal. Let's try to figure out what makes sense at the bottom here. So we went back to existing data to see how long the fastest 50% of transactions took. To our surprise, it was a lightning quick 100 milliseconds. With our fast and slow boundaries defined, now we can make steps up towards our SLA. It was decided that OK behavior was defined at the 90th percentile, which takes 1,000 milliseconds. And when that occurs, let's give the ops teams a heads up with a Slack message. Going further, we could also define laggy behavior to be when the 95th percentile is at 1,500 milliseconds. And when that SLO is breached, let's submit a formal ServiceNow ticket. And finally, our last SLO before we get to our SLA, when the 99th percentile hits 1,700 milliseconds, clearly something is wrong and we should page on call. So there you could see how we took a big architecture, broke it into one journey, then set various goals and codified which actions we wanted to take to actually make that request happen within a certain time. Moving on to the second journey, it's clear that this flow is much more complex. However, we can still follow the same patterns of codifying the reliability necessary for the SLA, examining the system behavior to see where the 50th percentile is, then working away towards middle settings that are reasonable targets or actions that could be taken. See, when you follow the slow DLC, even some complex architectures can still be broken down, instrumented, measured, and you can create SLOs that are easy to understand and manage and track. Now we move on to our third case study, StormCloud. StormCloud is a low-code development platform that wanted to model the reliability of their customers' build environments. Due to the nature of these build environments, they were looking to design SLOs that fit unknown or constantly changing architectures. To further complicate matters, there also were competing technology stacks, the traditional and the next generation. They needed an automated solution that could dynamically fit into their build pipelines to measure the reliability of their customers' environments at scale. They did so on the traditional infrastructure by adopting the OpenSLO spec, setting generic reliability targets, and adding additional actions to create, update, and destroy SLOs on demand as new environments are built and torn down. On the more modern parts of the infrastructure, they were able to utilize Terraform modules for configuring error rates and thresholds. These SLOs also were able to utilize both time slices and occurrences for different needs. At first, what seemed to be a daunting task, StormCloud was able to create two independent solutions to scale and implement out their SLOs in a very generic manner. Next, we have StreamsRS. StreamsRS is in the entertainment industry where they provide streaming video globally. They needed SLOs to measure the latency of their streaming service in order to exceed contractual obligations and stave off competition with other streaming providers. After spending time discovering, designing, and implementing their SLOs, they started seeing a cycle reviewing their SLOs. The SLO here was clearly underperforming, and after analyzing, there were several one-off events that were triggering their reliability targets. However, looking slowly at the SLI chart, we were able to diagnose an issue that was contributing to the reliability targets. Let's pause for a moment and try to verify it. Okay, here's the answer. After 24 hours, the cache would refresh at exactly the same time, triggering a 30 to 40-minute spike in latency every day. When you review your SLOs, you gain insights about your infrastructure dependencies you didn't even know were affecting your user experience. Next steps. If you'd like to learn more about SlowDLC, check out our website, slowdlc.com. And if that interests you, please join the conversation on Slack. And if you have additional ideas of how this can be improved, please visit our GitHub, help the community out to make the documentation better. Something in which we did in designing SlowDLC was we created all these definition documents and templates in Markdown with the idea of that they could live side by side along with your code and also with your SLO targets and the reasons why you're setting these reliability targets there to help aid folks during an incident or understanding why these things are set in certain ways. And with that, I bid you farewell. My name's Sal Farino, and I'm a customer reliability engineer at Noble9. And if you'd like to learn more about SLOs, please check out noble9.com.